So today, let me go ahead and go back so you guys can see this right here really quickly. Okay, clear. Okay, so here we go. Learning objective for today, guys. We're going to go and apply the secant-secant and secant-tangent product theorem. Very similar to the chord chord, yet different because we have different cases that are happening with our beautiful segments and lines. So let's go ahead and review very quickly. We have our beautiful arcs in all of our parts. We have this. We have a tangent. So remember that a tangent is a line that intersects our beautiful circle at exactly one point. And that point, we call it the point of tangency. And now we have the recall of our secant. So remember that our secant is a line that intersects my beautiful circle, not at one point, but 2 points, right? Now, we're going to go ahead and see those 2 points happening with the intersection, but it's also going to intersect another secant in the outside, right? So if they were to intersect inside, we would call them chords. If they were to intersect outside, we would call them secants. So this is our theorem. You should have the definition for secant already. No? Yeah, you guys have it. Yeah. So here is our beautiful theorem for secant-secant product in essence. So go ahead and copy this one down so you guys can have it. So this one states that 2 secants intersect in the exterior of a circle. So here's our intersection happening at point E in this case. We're going to go ahead and have the entire segment of that secant and its external piece. We're going to go ahead and multiply or have the product of those 2 parts. And we're going to go ahead and make it equal to the product of the lengths of the other secant segment and its external segment, or its external piece. So here we have a beautiful equation, and I'll go ahead and explain to you guys what the parts are, okay? So we have the entire secant segment, and we're going to go ahead and multiply it or have the product of the external piece. And it should be the same value or be equal to the entire secant times its external piece, okay? So I was able to color code it so you guys can see. So my entire secant is going to be from A all the way to E. So it's right there. Now we're going to go ahead and use its external piece, which is from the outside of the circle all the way to where it intersects the other secant, which is BE. And the same idea where it should be equal to the same product of the entire other secant multiplied by its external segment or its external piece, okay? So we're going to have those 2 products made equal to each other. So copy this down if you don't have it yet. All right, so now that we have this, we're going to go ahead and apply the beautiful secant-secant product theorem. So like I said, we're going to go ahead and use the entire secant. So let me go ahead and highlight the part so we can see what's happening. So my entire secant is from A to C. So from A to C is this. Let me go ahead and write that down. AC times the exterior part. Its exterior part is from A to B. So it's right here. Let me go ahead and write that down. Times A to B. And this is going to be made equal to the other entire secant. The other entire secant should be from A all the way to E. And it's going to multiply from A to E. It's going to multiply by its beautiful external part from A all the way to D. From A to D. Okay. So now that I wrote my beautiful equation, we can go ahead and substitute the values. So let's go ahead and look at the first one. What's the first one, guys? The first segment is what? AC. What is the measurement of AC? X plus 5. We have to add both parts together. So in this case, I'm going to go ahead and write X plus 5. So in parentheses, X plus 5. Now, that portion or that little segment is going to multiply times the external piece. The external piece is AB, which is 5. Okay. Now, let's go ahead and do the same on the other side. AE. AE is 6 plus 6. And the external piece is 6 in this case. Now, it looks sort of weird because I had to write every part of it so you guys can visualize what's happening. Now the easy part comes in play because we're going to go ahead and simplify, which was what we love to do. So we have x plus 5, which is x plus 5. And 5 is going to be multiplied outside. I just like to move on my beautiful coefficient in the front. 6 plus 6 is 12. And this we're going to go and multiply again by 6. Now looks more familiar to how we like to see our beautiful terms arranged. So what do we do with this 5? Distribute it out. So we have 5 times x, 5x. 5 times 5 is 25. 6 times 12 is 72. And now we have our two-step equation. We can do our inverse operations. What's our first inverse? Subtract 25. We're left with 5x equals. If we need to borrow, guys, we have 6, 12. 12 times minus 5 is what? 7. 6 minus 2 is 4. And divide by 5. Obviously, 5 does not go into 47 exactly, so we can have an approximate value. So how many times does 5 fit into 47? 9 times and some change. What's that change? It should be what? 9.2. Yeah. There you go. Now that's the value of x. So this is 9.2. Now we have to find the value or the measurement of each secant. The first secant is from A to C. So AC should be measure what? 5 plus 9.2. 14.2. And the other one, we already have it, AE. AE is 6 plus 6, which is beautiful 12. Woohoo! Not too bad, right? Let me go ahead and save an image so I can have it for you. Okay. You guys ready to apply this on your own? Okay. So what are we doing for this rule? The entire segment times what? The external part. Entire segment times the external part, okay? So everybody has this? Go ahead. All right, go ahead and try number 2 on your own. Let's see what you guys got. So I'm going to go ahead and multiply my entire segment, which is, write my entire segment. Here's my pen. 6 plus 8, which is 6 plus 8 first. So it's the entire segment. So 6 plus 8, let's go ahead and write it out. And this is going to multiply by the external piece, which is 6. Okay, so we have 6 plus 8. Can somebody open the door? Oh, yeah. All right. And it's going to be equal to, so it's the entire segment, which is x plus 7 times the external piece, which is 7. There you go. I'm going to go ahead and write it out here. All right, so we should have something looking like this. Now, if we need to write down our parts, we can go ahead and write our parts. Remember, that's our entire beautiful segment. In this case, it's SP. So SP is right here. My exterior part, guys, is RP. And it has to be equal to the multiplication of the exterior part. So we have TP and the entire segment that we have here from U to P. From U to P. Okay. All right. So we have 6. Inside we have 6 plus 8, which is 6 plus 8 is what? 14. And over here, we're going to go ahead and distribute. So we should have 7x plus 49. Okay. What is 6 times 14? 84. So now we have our beautiful two-step equation, and we can go ahead and solve all the way through. Victor, pass it on. Isaac, how do we solve? Two-step equation. Let's start with our constants. There you go. Let's go ahead and subtract 49 on both sides. We're left with, again, if you need to borrow. 14, and this is 7. 35 equals 7x. Last step. There you go. Divide by 7. So x should be equal to beautiful 5. Raise your hand if you got that. Ándale, no que no. All right, so this is 5. Now we can go ahead and find each of the secants. We already found SP. SP is 14. And all we needed to find is UP. UP is 5 plus 7, which is beautiful 12. Okay. All right, how do you feel about these guys? Okay, so the next one, guys, the last one is very similar yet different. It's the case where instead of having two secants, we have a secant and a tangent. So go ahead and copy this one down. Secant-tangent product theorem. Very similar. We still have our two parts. The entire beautiful, go ahead. The entire beautiful secant times its exterior part. So we have AD times its exterior part or external part, BD. Now, my other segment is not a secant, it's a tangent now. So it only intersects our circle at one point instead of 2 points. So we have basically the segment itself, so DC, times its external piece, which is also DC or CD. So instead of writing CD times CD, another way to write CD times CD is CD to the power of 2, okay? So they're still present there. That just doesn't mean that it's not considering the parts. It's just we're now writing it to the power of 2 instead of writing it separately, okay? So we're still applying the same idea.
His last name,
Yes.
Oh, yeah, it was.